In this tutorial, I will be discussing the answers of those questions, starting from question number 1. If the current passing through a conductor is doubled, what will be the change in heat produced? Okay, let us write the formula once again. The formula for heat produced is H equal to I to the power 2 into R into T, where I equal to electric current in ampere, R equal to resistance in ohms, and T equal to time in second. So now, if the current is doubled, that means I becomes 2I. It is doubled. I will become 2I. Then heat produced will become 2I whole square into R, 2I whole square into R into T. That means it will become 4 into I square into R into T. That means heat produced will become 4 times more. So if the current is doubled, heat produced will be 4 times more. Let me clear this space so that I can write my next answer here. Okay, let us go to question number 2. Two effects produced by electric current. The two effects produced by electric current are, one is heating effect, another is magnetic effect. In this chapter we discussed quite a bit in details about heating effect. In subsequent chapter we will be discussing magnetic effect of electric current. So these are the two prominent effect of electric current. Now heating effect of electric current is used in devices like electric iron, electric heater. Magnetic effect of electric current is used, it has very interesting use. One recent use you might be seeing in induction oven. This is a picture of an induction oven. Here in induction oven uses magnetic effect of electricity. How it works? This is how it works. In an induction oven, electric current is passed through copper coil. The copper coil is below, it is not visible here, which produces magnetic field. Because electric current produces magnetic field, the magnetic field vibrates the molecules of iron of the utensil which is used for cooking. The vibration of the molecules of the utensil produces heat. As such, the induction oven never feels hot, as it only produces magnetic field and not heat. So this is one very interesting aspect of induction oven. Even when it is working, if you touch the oven, you will not feel the heat, because it only produces magnetic field, and this magnetic field vibrates the molecules of iron. So induction oven will have a special type of utensil. Question number 3. Electric bulb uses the heating effect of electric current. Question number 4. Heating effect of electric current is due to transformation of energy. Transformation of electric energy into heat energy. Question number 5. When we rub our hands, mechanical energy transforms into heat energy. So first blank it will be mechanical, second blank will be heat. Question number 6. Two devices which uses heating effect of electric current. One is electric iron, second is, you can write, electric heater, like water heater or room heater, something like that. Question number 7. Name few gases which are used in electric lamps. One you can write nitrogen, another you can write argon. Basically they will not enter into reaction with the filament. Question number 8. Filament type lamps are not power efficient. Why? This is very interesting. Let me write in a fresh writing pad. Okay. Now in filament type lamp, what happens is current flows through the filament. First it becomes very hot, and then it becomes so hot it starts radiating light. So it produces lots of heat. First it is getting heated. That's why if you touch the filament type lamp, it always feels very hot. So the heat energy that is produced, we don't need that. So it is not very efficient. Lot of heat energy is produced, which is basically a waste of electric energy. On the contrary, fluorescent lamps are very efficient because here heat is not produced. It works in a different way. So first, in filament type lamp, current passes through the filament becomes very hot, then it starts radiating light. So it produces lot of heat which is not useful, only light is useful. So in order to produce light, it has to be heated, and lot of heat energy gets wasted. So it basically that is the reason why filament type lamps are not really very very efficient. State and explain Joule's law of electric heating. First let me write the formula first, and from that formula I will explain the Joule's law. The formula for producing heat is H equal to I square into R into T. That means H is proportional to I square when R and T are constant. Again, H is proportional to R when current flow, that is I and T, are constant. Current flow and time, these two are constant. Again, heat produced, H, is proportional to T when I and R are constant. That means current flow and resistance are constant. So these are the laws of Joule's law of electric heat produced. Heat produced is directly proportional to square of current, directly proportional to resistance, directly proportional to time. So these are the Joule's law of electric heat. Okay, question number 10. If the current passing through an electric kettle is doubled, heat produced will become 4 times. We have already discussed this in question number 1. Basically it is coming from the same formula, H equal to I square into RT. We already discussed this in question number 1. Question number 11. An electric fuse works on heating effect of current, because when the fuse gets heated, it has a low melting point and it melts and disconnects the circuit breaks. Question number 12. If current is doubled, heat produced will become 4 times more. This is again we discussed in question number 1 and question number 10.